one of the problems with using derivative plots to find an equivalence point is that the titration data itself is actually least accurate at the equivalence point because you have the least amount of buffering in the solution. So you will see big jumps in pH, and the response of the electrode can be sluggish. So your pH electrode may not keep up with the changes in pH, and so you may not get the best reading from a derivative plot. A Gran Plot helps to get around this because it actually uses the data from before the equivalence point to then locate the equivalence point. So the derivation of the Gran Plot is in the textbook if you want to look it up. But basically what you're doing is you're taking the volume of the titrant. In this case, the titrant is a base. This is formulonic acid times 10 to the negative pH. And you're plotting that against the volume of the titrant. And that will give you a plot that looks like this. And you can see that it is linear, and we extend the line down to where it crosses the x-axis, and that gives the equivalence volume. These points here have not been included in the linear regression because they don't fit into the linear regression. If you're going to titrate a base, so this is for titration of an acid, the one that's on the slide. If you're going to titrate a base, then this becomes volume of the acid on the x-axis, and the y-axis becomes volume of acid times 10 to the positive pH. So notice the change in sign in the exponent when you're titrating a base. So if you're titrating a base, so that would mean the titrant would be acid. So you'd have VA and VA, and then 10 to the positive pH up here. So for creating the Gran Plot, you generally want to aim to use the last 10 to 20% of the volume before the equivalence point. So what we have here, this has actually gone a little bit farther than that. It's got about the last 30%. And if you actually look at this, this is actually starting to curve this way a little bit. So that maybe that point should actually be taken out. Maybe a couple of points at the top end should be taken out because we have gone a bit beyond the 30%. So I just want to show you how you create this Gran Plot so that you can get this equivalence point where your projection crosses the x-axis. Okay, so all right, so this was the graph we just did, and we want to do a Gran Plot on this first equivalence point here. So we need to pull out the data around that first equivalence point, and we know it's going to be around 30 milliliters. So I'm going to go scroll down my data, and I'm just going to copy and paste the data that's around the 30 millimeter point. Oh, I'm reading this backwards. Okay, so I'm going to start here at 20, and I'm going to go up past 30 milliliters, and I can always take points out later if I don't need them. So I'm going to go all the way up to 35. And all I'm going to do is copy and paste this somewhere else on the spreadsheet. So copy, and then, oh, actually, it's already up here. It's already been pasted up here. So I won't bother to paste it. Okay. Sorry, I'd forgotten I'd already put it up here. So this is just the data from 20 to 30 milliliters, copied the volume and the pH, and then I've calculated the volume times 10 to the negative pH numbers here. I don't know why those are numbers and not a formula. And I don't know why. Oh, I know why I have it twice. Okay, so it would be equal to this times 10 to raised to the power of negative of the pH. Doesn't want to let me click on pH. Yeah, okay, fine. I know you want another number in here, but you're not going to let me click. Yeah, it's not happy. All right, I'll just drag that down there. Okay, there we go. And then I could drag that down all the way. I know now why these are numbers. I do know. You'll see why. Because I'm going to have to move them, and it's easier to move them if they're numbers. So if I copy this all the way down, now these are all formulas. If I want to make them all numbers, I'm going to do a copy, and then I'm going to do a paste, but I'm going to do a special paste, so I just right-clicked on this cell, and I want to paste as values. So that's what that is. And now I'm just going to delete these and move this back over. Okay. There's method in my madness, I promise. All right, so our graph is this value versus this value. So I'm going to highlight the whole thing, and I'm going to highlight this next column. You notice I have two columns labeled the same way. And as I said, there's method in my madness. I want an empty column. It's labeled the same. It's going to have the same values in it, but you will see why we want to do this shortly. So I'm going to insert a chart. Just scatter plot. There we go. There's our chart. The first thing here, this is the pH. We don't want that one. We want this one. So there's our Gran Plot. And what I'm going to do is I'm going to format the x-axis because I don't need all this extra space below 20 milliliters. So there we go. Axis options. I don't need the minimum to be 0. The minimum can be 20, and that's going to spread my points out. That looks better. Okay. And I'm going to take the grid lines out because they annoy me. All right, so what I want to do, and I don't need a legend because there's only one set of data on here. So again, it needs a title, it needs axes labeled. But what I'm going to do is I'm going to add a trend line. And it's linear, and I'm going to display the equation and display the r² on the chart. Okay, so there's my linear regression. And if you look closely at this data, you'll see it's actually giving you a wave here. So you can see it's going above the line and then crossing the line and coming below the line. So not all of these points are actually in the linear portion. And so this is where this extra column comes in handy, because what I'm going to do, I'm going to move points out of this series and into the other series. And it's really easy. I'm just going to drag it over here. So now you can see this last point is gray instead of orange. It's in a different series. The r² has improved. And we're just going to we're going to look at the graph. What we want to do is we would like to see all of those points on the line. So our regression is improved and our r² should also improve. So we had 9959, we're now at 9978. I think this top point also should be taken out. Oh, that's looking better. So the r² did not improve dramatically. Okay, so there's 988. Let's try one more at the bottom end. No, that didn't make any difference in our r² value. What if we take out one at the top end? I think that might be our best bet. And so I'm eyeballing the line where the data is falling relative to the line, and that r² value. So sort of a bunch of different parameters we're looking at here. We want the points to be on the line. We want the gray points to be obviously not on the line. And again, this one is maybe a little bit debatable. This last one, it did improve the r² slightly when I took that off. And it went from 0.999 to 0.9995. But I think that looks pretty good. And I don't want to have too few points actually on my line. So now this Gran Plot, we suggested going back 10 to 20% of the volume, so that we'll be back about up to 6 milliliters. We're going to 8, which is a little bit more, but I still think that's fairly reasonable. Oh, the other thing that I should point out is because this plot, oh, come on, don't be like that. There we go. Because it is including all of these blank spots, the line is actually extended beyond the data, okay? So if I look at, it's not going to let me click on an orange point. Oh, excuse me for a moment. Okay, sorry about that. Okay, so we've got our line here. It seems to be pretty good. As I mentioned, it does extend all the way through. The other way to get the line to extend, if it's not doing that, is if you click on the trend line options. And what you would want to do is go down here to where it says forecast. either forwards or backwards. So forwards meaning to more positive x values, and backwards would be to more negative x values. And the periods here is sort of the units on your x-axis. So you can extend it forward or backward by plugging numbers in here, and that will extend the line. In this case, because we have actually for the series highlighted beyond the points that we're using, so again, we can see that we've highlighted for both of them actually all the way down through the whole X range. It's extending the line for the whole X range. So then to get the equivalence point is where this line crosses the X axis. So that would be y equals 0. So you're going to plug that into this equation and get your X value. One of the things I'm noticing on this right away is both the slope and the intercept only have one sig fig. So you would either want to format that, and you can see here the formatting has come up. You can make it scientific notation, and that will give you more sig figs. Or you could do a line est on the data. So just do a line est on these points, and then that will give you it easily with more sig figs. Okay, so that's the grand plot.